Okay, let's go through this work example 3.3, design of a wet sediment basin. This is the one that I asked you to go through on your own just now. This is for wet sediment basin. Just now we were doing the dry sediment basin. So this is the spreadsheet that you download. Wet sediment basin 1A. To design a wet sediment basin and outer structure required for a construction site in Ipoh. To design a wet sediment basin and outer structure required for a construction site in Ipoh. The data is as follows. The basin type is earth embankment and perforated outlet. It's shown in appendix 39.B. Soil type is sandy loam. Construction period less than 2 years. Area 8 hectares. Data for your computation for using the French formula, the overland flow is given there. So the data for your drain flow also given. So I go through each of the major steps quickly. First is to calculate the TC, the time of concentration. So we use the rational formula here. Calculate TC using French formula. Okay, it's same like what we did for the dry sediment basin. We get the TC. And overland flow plus drain flow equal to time of concentration. Next is the size of the sediment basin. To size the sediment basin. On table 3.3, we have soil type F, construction time less than 2 years. The 75 percentile for Ipoh is 36.75. Refer to table 3.4 for other locations in Malaysia. This one is not given in MSMA. So to do the 5-day storm, all this for the major town is already given inside our workshop training guide. You can refer to it, but if necessary, you can still do yourself. If you want to do a sediment basin for Saliran, you can either use the one inside the training guide, or if you are not confident, you are not happy, you do yourself and compare. See any difference or not. So the sizing is based on the 75 percentile, and you read from the table. The required storage zone volume, required total volume. This value 176,264. We assume moderately high runoff. For most of the cases, it fit into moderate to high runoff. Only for sensitive area, maybe you consider very high runoff. Let's say you are doing work in Cameron Highland, or you're doing work in Genting Highland. You're doing work even in Bukit Tinggi. All these famous for erosion. All these places, hazard. Go for very high runoff. the sizing of the sediment basin is there. You calculate. You see, the formula is so smart, you know what value you use. If you put this to something else, to very high runoff, the formula will change. See the formula or not? See the formula inside here? You will detect whatever you put. Anyway, you can always check by hand calculation whether it's working the way you want it to work. Okay, E28 times this one, this one E29. You take these two values, 176 and 264, you put here 176, 264, you times the area, you get this. You get the settling zone volume and the total volume. So next, settling zone. Settling zone depth is 0.6. Tri average width is 30. Average length is so much. Check the settling zone dimension. Settling zone. According to this table, you calculate settling zone depth is 0.6. The settling zone average width is 30. Required means you divide it this way. Length, you get the length is 30. Then you check the length to width ratio, length to depth ratio. Okay. Okay. So we put in 0.6, recommended by Mesra. You put your cursor there. I comment. It's recommended. Settling zone. You try even read. Then you calculate automatically. You try a read of 30. Then everything okay. If you try a read of 60, no good.